Record. Yes, I know recording's in progress. There we go. Okay, share screen. Back to this again. Oops. Okay, there we go. Okay, so if you haven't printed it off already, I'll put it up on the screen here. Let me read you a story. I don't know if any of you like murder mysteries. Murder mysteries are kind of interesting, I think. Trying to figure out who done it, right? There used to be a really big party thing, right? You used to go to murder mystery parties, and they would throw stuff out like somebody would be the person you had to do it. I don't see the option to evaluate. Oh, she said it was up there. So if not today, check tomorrow. Okay, so let me tell you a story. Cameron Day, nice person, was killed just outside of Gimli at 11:45 on February 14th. So Valentine's Day, he was killed. 5 men were brought in by the RCMP. And a week later, they were questioned by this guy named Detective Remington Irons. If you know the reference to that was Remington Iron was Pierce Bronson, I think. It was an 80s TV show. Anyways, each man made 4 statements. And you could see, right, Alex, Boris, Edgar, Frank, and Gabriel. They all made 4 statements. Okay, and you can read their statements. They're on the screen there if you want. Right here, I'll get them a little bit larger here so you can read them. Now, what happened is each person that made the 4 statements, they made 4 of them. 3 of them were absolutely true and 1 was false. Okay, so for instance, Alex, his 4 were I was in Vancouver, I never killed anyone, Gabriel is a guilty man, Frankie and I were pals. So there's the 4 statements. 3 of those are true and 1 of those is false. Same with Boris, 4 statements, 3 are true, 1 is false. Same with Edgar, same with Frank, same with Gabriel. Okay, one of these 5 men killed Cameron Day. So what you need to do is you need to use your critical thinking skills, use your powers of deduction, and figure out which one of these 5 people killed Cameron Day. Okay, so we're going to take a few minutes to do that. And if you don't get it in a few minutes, I'll give you a little hint. I'll put it up on the board. I actually have it already up there. That may help you figure it out. But in the meantime, what I want you to do is try to figure out who killed Cameron Day. Remember, of each person, 3 are true, 1 is false of the 4 statements they made. Okay, so take a few minutes and work on that, please. The person who just joined us with the iPhone, is that Lori?
Yep.
Yeah, see, I remember from last time it happened. I'll mark you here now.
Something's up with my laptop. It keeps updating every time I turn it on.
It might have been, if it hadn't been done for a while, then it's just going to do it until it finishes it. So you'll just have to run it in the background, but I mean, just stay on your iPhone for when I start teaching.
Yeah.
In a couple minutes, I'll give you a little hint on how to do this, guys. Okay, so let me give you a little hint here. Let me switch over to my whiteboard here. So you got to think about, if you've ever done a murder mystery before, right? What is the main reason that people have for an excuse? What's it called?
An alibi?
Yeah, it's called an alibi, right? An alibi could be a number of things. It could be based on a person, right? Or it could be based on a location. So think about this for a sec. Let's just look at Alex right here. So Alex said, I was in Vancouver when Cam was killed. So that could be an alibi, right? What about one of the main things they do is when you get put into court and they ask you, you either say you're guilty or not guilty, right? You plead guilty or you don't. You plead guilty or not guilty, right? So think about this. There's 4 statements up here that Alex said. 2 of these are really kind of garbage. They're useless. They have no basis in this at all. Which 2 are the garbage ones?
I think it's the ones that start with the names. That's just a guess.
Oh, so you're saying Gabriel is the guilty man. Yeah, okay. That really has nothing to do with this because he's just saying somebody else is the guilty man. Okay, so we can get rid of that. And Frankie and I were pals. Who cares if him and Frankie were pals? That has nothing to do with this murder. Okay, so those are gone. So what we're left with is, you can see the 2 that are left at the top. Okay, so these right here, if you look, these where I'm putting the arrows, these are the 4 possibilities, right? Based on, remember, 3 truths and 1 false. Okay, so let's look at the first one. So if it's the first one, I was in Vancouver when Cam was killed and I never killed anyone. Both of those are true, correct? So that eliminates that possibility. Same with the second one, both are true. Okay, so those are useless. Both of those are useless to us. But let's look at the last 2 and see what makes sense here. So we either have true and false or false and true. That's the only options. So let's look at the third one here. We're looking at this one here. So he was telling the truth about being in Vancouver, but he's lying about never killing anyone. So it has nothing to do with Cameron Day. He might have killed somebody else, But it's regardless of that, it makes no difference because this is the overriding one in this one. He was in Vancouver. He couldn't have killed Cameron Day because he was in a different province. Okay. Look at this last one here. So let's say he was lying about being in Vancouver, right? Why are those the only two options? How do we know that one is true and false? Well, if you look what I did here, Sam, true, 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 false, right? If you read the question, it says 3 are true, 1 is false. So these are all the possibilities that it could be, right? And we've just eliminated the bottom 2 rows, and these ones here, both are true and both are true. It makes no difference, okay? So on the last one here, he's lying about being in Vancouver, but he's telling the truth about never killing someone. So in this case, he just lied about where he was. So this one is the overriding anyways. So what happens is based on that, could Alex have committed this murder?
Yep.
Nope, not at all.
But
There's no
how do you? Sorry, go ahead.
Go ahead, what were you gonna ask?
I still don't understand. How do you know which, like the true, 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 false, true, true, false, true? How do you know, like, which, what are those truths referring to? What are the false referring to? There's only 2 statements there. I still don't understand how you get the conclusions you got, but
I don't know where you're asking. Like from the beginning, the true, like are you asking about this true, true,
yeah,
true, false?
yeah,
Okay, the question says, each of the man made 4 statements, right? So there's
Yeah.
Alex's 4 statements. 3 are absolutely true and 1 is false. So if you look, true, 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 false, that's one set. True, true, false, true, that's another set. True, false, true, true is another set. And then the last one, false, true, true, true. That's the only possibilities it could be because 3 are true and 1 is false. There is no other way it could be anything else. It can't be 4 trues. It can't be 2 falses and 2 trues, right? Because it specifically says 3 trues and 1 false. Okay.
I see that now. Yeah,
Okay. So then what it is then we went through and we got rid of these 2 statements. You said that because they were basically useless statements, right? They have nothing to do with the case in this case. So we can eliminate, like we did, we can eliminate those right off the hop. So then this top row, the 2 top rows are the only possibilities. So the first one, right, that we did here, the first one is true, true. That's one possibility. Perfect. That means he didn't do it in this case. Next one is true, true. That means he didn't do it in this case. Now in the third one, he's lying about one of them. So he's lying about killing somebody, but he's telling the truth about being in Vancouver. So obviously based on that, who cares that he was lying about killing somebody? Obviously he killed somebody else, but he's truthful about being in Vancouver. Well, that's an alibi. So he couldn't have done it in that situation. And the last one, he's lying about being in Vancouver, but he's absolutely telling the truth about never killing anybody. So there's no way he could have killed Cameron Day, right? So this is a no for him. Okay, so what I want you to do, based on that pattern, right? You can now go through the other 4. You could go through Boris, Edgar, Frank, and Gabriel. So what you're gonna do is you're gonna set up the pattern just like I did there. True, 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 false, true, true, false, true, right? Try to eliminate 2 of the possibilities, and then based on that, using your reasoning, figure out if that person did it or not. Okay, I'll give you a few more minutes to figure that out.
Why did you have 3, 4 true and falses?
Sorry, what was that again?
Why do you have 4 true and falses?
Because those are all the possible options, right? He made 4 statements and it says 3 are true, 1 is false. We don't know which pattern it is. So the first column, true, 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 false, that's one possibility. True, true, false, true, that's another possibility, and so forth, right? That's why we have the 4 columns of true, true, falses, right?
Okay.
That's the only that's the only outcome. I mean, we can't add a 5th or 6th column because that's all they give us, right?
Oh, I missed this part from the.
Sorry, what was that?
I missed this part from the directions, I guess.
Okay.
I came in late.
Does somebody want to take, now, hang on before you answer this. Does somebody want to take a guess, an educated guess on who they think killed Cameron Day? Now, if you tell me who you think killed Cameron Day, you have to explain it also.
I say somebody who didn't.
Okay, so let's start with that. Which one? Okay, so we know Alex didn't do it. Who do you think didn't do it?
I don't think Gabriel did because 2 of his statements contradict each other. Like if he says, I did not kill Cameron, then he can't say Alex lied when he said I was guilty.
But based on the properties that I gave you, I did not kill Cameron's like either guilty or not guilty. But what about the second statement?
Alex lied.
No, the second statement on the thing, I've never been to Gimli.
Oh, well, see, I didn't use your style. I
Oh,
used
you
logic.
didn't. Okay.
I used like linguistic logic instead, but
Oh,
I mean, I didn't get the
you're
answer.
using that fancy stuff on us, eh?
I didn't get the answer, but I tried and I came up with that those 2 responses contradict themselves. So
Okay, so that does work in Gabriel's case. But even if you do it with the true, true, false method, right? The first 2 are the most important ones. So even if he's lying about killing Cameron, he was telling the truth of never being to Gimli. I mean, he couldn't have killed him anyways if he was never in Gimli. So
Exactly. Yeah.
you're correct on that. Gabriel is not one of them. Okay, so Alex and Gabriel are gone.
Can I solve it?
Sure, Eric.
So we already discussed why Alex and Gabriel can't be it.
Correct.
So Boris, he says, I was in Winnipeg on the
Right.
night of Friday the 14th, and I did not kill Cameron. See, no matter which one of these is true or false, it disqualifies him from being it. And
Correct.
The same thing, Frank. He says, I was in Winnipeg with Boris on the night of February the 14th, and he also says, I did not kill Cameron. So one of these is true and one of them is false. And if the one in Winnipeg is false and the I did not kill Cameron is true, then it disqualifies him. But if I did not kill Cameron is false, then how could he have been in Winnipeg?
Correct.
So it has to be Edgar.
It has to be Edgar. Cool. Anyways, it's a different kind of, it's a different puzzle, right? It's based on some logic, right? Whether you can do what Lacey was doing and doing linguistic logic about contradictory statements, or like what Eric just completed there with the true, true, false stuff. Either way, you can deduce who killed somebody, like who killed Cameron Day. Anyways, another activity. Maybe it's math related, maybe it's not. In some ways, it's that logic stuff when we talked about way back, that inductive and deductive reasoning. I don't know, I can't even remember how long ago that was, right? We talked about that. It's the same concept there. Okay, so we are doing congruence, construction, and similarities. This is very similar to the stuff we did yesterday. And it's really quite short. Like, I think slide-wise, it's a small section, like 21 slides, and then there's only exercises on 12.1 and 12.3. And then I have a bunch of activities. So, right, so if you can't see those, let's go to the activities here. And some of them, of all of these, if we get to this, oh, by the way, you know, if I had paid attention yesterday, remember I was talking about the Tessellation Project, the one I was talking about yesterday? I linked it in today's lesson already. I forgot about it. So this is that whole tessellation thing we were talking about yesterday. We'll talk about it when we get there. Yahtzee Cribbage. And the most important one, if you take anything from this lesson, do me a favor, either buy yourself this game, and it's $15 on Amazon or any place you want to order it from. It's called Set, and we will go over it. And there's a daily game right here, and I will show you this. It is probably one of the biggest educational tools you will ever use, and it is super fun. And I'll tell you a story about how the first time I played it. You may care, you may not care. Okay. So let's do congruence, construction, and similarity in slideshow from beginning. Here we go. So congruent triangles. So let's talk about congruent triangles. Two triangles are congruent if and only if there is a correspondence of vertices of the triangles. It's sometimes the wording is just silly. Here's the deal. Sides and angles are the same. That's really what it is. If you have corresponding sides and corresponding angles, you have something that is congruent. Now, there is a ton of these rules. You may remember these rules, you may not. And as soon as you see the letters, you might remember them. The first one is called the side congruency property. Sorry. If three sides of one triangle are the same as three sides of the other triangle, then the triangles are congruent. So for instance, if the number was like 4, 6, and 5, and these other ones were 4, 6, and 5, they're congruent. It's called the side theory because all three sides equal each other. Okay? That makes sense so far? First basic property. Now, sometimes you're not going to get all sides. So the next one, by the way, is this bringing back any memories when you learned this a long time ago? Is this bringing back any memories? Nightmares, memories, similar things, right? Okay, the next one, the next one is side, angle, side, right? And if you look here, it has to be in that order. It can't be, well, we'll talk about that coming up. This one, it's side, angle, side. So the blue one, this little blue hash mark here is the same as this one. The angle, you see the little red mark is the same. and this side and this side, the green ones are the same. So that means if those things are the same, then you have two triangles that are congruent. Okay. So side, 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 side angle, side. Now we have something called the isosceles one. Do you remember what an isosceles triangle is?
Is it when two are the same, but one is different?
Two sides.
Two sides are the same and one is different, correct. And these ones here, you can see right here, these two sides are the same, which also means then that these base angles here, and again, this whole triangle could be spun around. Those two sides are the same. That means those two angles are the same. And then you have congruent triangles. Okay. These two things, and we'll get back to properties in a sec. This one's kind of neat. It's called Thales Theorem. And you might have remembered this. If you have a semicircle, half a circle, right? And you inscribe an angle, which means draw, inscribe, scribe, or draw an angle in there. Wherever it reaches on the far side of the circle will automatically be a right angle, no matter where you put it. So for instance, if I drew one from B, and if you can watch my mouse, if I drew one from B over to this side of the semicircle and then down to A, that angle would be 90 degrees. Okay. That has a lot to do with when we're dealing with right angle triangles and congruency with right angle triangles. Okay. Now let's get back to the properties. So the first one was side, 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 SSS. The second was SAS, side angle, side. This one is angle, side, angle. So again, you have to have the pattern. Angle, the red one, the side, the blue one, and the green double angle over here, that one. So that's angle, side angle. So if you have two, and what I'm saying is, for instance, if this was 30, this was 10, and this was 40, and this was 30 degrees, 10 and 40 degrees, angle, side angle, they're congruent, right? Works out. Okay, so that was side, 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 side angle, side angle. And let's go back to the isosceles one. Remember that this isosceles was, if you have two sides are the same, then the base angles are the same. Well, that also works backwards, right? So if you have two angles that are the same, right, base angles that are the same, what that tells us that then those sides automatically have to be the same, right? Okay. And the last property of these ones for congruent triangles, and I've done this before when I make an ass out of myself. Oh wait, no, that's not what it's called, sorry. AAS, right? Angle, angle, side. Okay, so if you look at this one, we start with the green ones, right? There's the angle, then the red one, then the blue side after that. Now, if you think about this, it actually makes sense because, for instance, if you know this red angle and this green angle, you can automatically figure out this empty angle over here because all three angles of a triangle equal
180.
180, right? So that rule is always in place. So really, you know, three angles, right? So you could go angle, side, angle if you looked at it a different way, right? But in this case, it's angle, angle, side. That's another property. Do you guys remember these at all, or is this new for some of you? Put a thumbs if you remember it, and put an X if it's new, if you don't mind, just so I can kind of get an idea.
Just a quick question about the symbol between the two triangles.
Right.
Is it equal? And then I thought the little wavy guy was approximate or estimate.
Yes. Most times when we do math, right, we actually put that in there as approximate. It's technically wrong, right? Normally it's one line with a squiggle over it. That's usually used for approximate, or they'll do double lines with the dot over it, right? You remember seeing that one? It's sometimes symbols are used incorrectly in math. This is the actual true symbol for congruence is what it is, okay?
Oh, okay, okay.
If you made that mistake on a test, you know what? I'm not gonna dock you for it, right? It's or an assignment. I'm not docking you for that because that's not worth anybody's time.
So
Okay.
it doesn't mean like approximate or equal to. That symbol on its own is
Means congruent.
Okay, got it. Thank you.
You are welcome. Okay, so that is 12.1. So 12.2, and at one time, This 12.2, constructing geometric figures. I don't know if you ever remember doing this. You would have taken a protractor and you would have taken a compass. Remember the compass is the one with the point and you put the little pencil in it. And you would have actually created a lot of these angles and sides and all that stuff. It was very common to do in middle years. They don't really do much of it anymore. Most of the time, what they want to know now is, here's the information, here's what it looks like. Tell me things about it. I want some general knowledge about it. So what we got here is I'm going to just do 3 of them. Rhombus, perpendicular bisector, and angle bisector, because those are the most common ones. Okay, so the first one is a rhombus, right? And if you remember what a rhombus is, it's like a square that somebody kicked over, right? So all 4 sides are the same, right? Angle B, this big angle, and D are the same, C and A are the same, but there's a couple things. So these are a bunch of points that are related to them. Okay, here, let me put them down here. So the diagonals, right? So this from A to C and B to D, those are angle bisectors. And what it means is, for instance, A to C here, it cuts A into 2 equal angles. That's what it means, angle bisectors. The diagonals, so B and D and A and C, are perpendicular, which means they cross at 90 degrees. The diagonals intersect at their midpoint. So for instance, AC and BD, when we cut them, we get a midpoint, which means if you look, M to B, M to D are the same length, midpoints, equal size. M to A, M to C are equal points or equal lengths, right? The sides are all congruent to each other, which means they're all the same, and opposite sides are parallel, right? Which means they never touch. So AD and BC, actually I said that wrong, AD and CB are parallel. Order does matter, by the way, when you're dealing with that stuff. Okay, so those who never thought a rhombus had so many different properties of it, right? And when you get into, for instance, when you're teaching that to early years and middle years, you're going to teach some of the common ones. Like for instance, they intersect, right, at 90 degrees. When you get into high school, you're going to have to teach all this other stuff. So if you never teach high school, right, you don't have to worry about it for your teaching. Okay. Equidistant property of the perpendicular bisector. They have such fancy names for these things. Equidistant property of the okay, look. So what we got here is we got a triangle, right? You see the triangle? ABP, ABP. That's what it is. Here's the deal. We're going to cut it in half. We're going to bisect it. So that red arrow is the bisector, and you can see it bisects at 90 degrees. Basically, what it's telling us is A to M and B to M are the same distance. It's cutting it in half. It's bisecting it, right? That's very important. When you see bisector, it's cutting it into 2 equal parts. It does make it a little bit harder to understand, but I mean, the thing is, you want to impress people by knowing math, so you throw out all those fancy words out there, right? I'm not just joking, Sam. It is, but I mean, if you understand the math, equidistance, which means it's an equal distance from each other, and perpendicular bisector. Perpendicular means it has to have the right angle. Bisector means it cuts it into 2 parts. And you're right, they probably could make it quite a bit simpler in language. And the last one of these ones of constructing are equidistant property of the angle bisector. So now on the last one, hang on, we did a perpendicular bisector. This one, we are bisecting an angle. So our angle in this case, right, FA, F prime, you can see it right there. This red line P, wow, boy, I don't know my colors. I think I need to go back to kindergarten. The blue line is the bisector, right? And it cuts it, and you can see this goes to that point at 90 degrees, goes to that point at 90 degrees, and it basically cuts this angle perfectly in half. And you might remember doing that if you ever used a compass and you had an angle and you put the point of the compass on there and you draw a line, and you put the point of the compass somewhere else and you draw a line, and then you can actually figure out what the bisectors are. It was actually kind of fun. I remember it when I was a kid, but they don't do a lot of it nowadays. Okay. Last thing is 12.3, which is similar triangles. Okay. Now similar, remember congruent had 2 lines with a squiggle over it, right? Similar triangles have just a little squiggle. Okay, that is similar. Okay. Now the big thing about similar triangles are they are not, Well, yeah, similar triangles have the same angles. Let's just be clear about that. Similar triangles have the same angles. So for instance, angle A, right? Now, if you notice, I'm saying ABC right here. Triangle ABC is similar to triangle DEF. Oh, if and only if angle A, now you see we switch signs, is congruent to angle D. That means angle A and angle D have to be the same. Angle B has to be congruent to E and C has to be congruent to F. Okay, so you can have similar triangles if all those angles are congruent. So that's the only thing there. If you have angles that are congruent, you have similar triangles. The other part of it is the length of those triangles, and this is way easier to look at when we actually look at a picture, which is on the next slide, right? There's a scale factor on everything. So for instance, the first image and the second image might be 2 times as large or half as large. Remember, we did scale factor already. So take a look at this one here. What we have is 2 triangles. Hang on, I gotta get this box out of the way. There we go. If 2 angles of one triangle are congruent, so look at angle A is congruent to angle D. Angle B is congruent to angle E, right? What does that mean about C and F automatically?
They're congruent.
They're congruent to each other, right? Now, but the problem is are these triangles then similar also? Nod your head up and down and say yes.
Yeah.
Yeah, they are, right? The only requirement on that for the congruency, right? Or sorry, for similar triangles is they have to have congruent angles. It doesn't really say anything about the sides. The only thing it does say about the sides, they have to have a scale factor. You can see the second one is larger, probably by a consistent scale factor, right? Oh, okay. So what that means is then what we can do is we can use those properties to solve things, which is really useful. So take a look at this one here. So we got a point, a tree. Where's the tree? A tree and point T is in line with the stake at point L. So here's our in line from T across here. And it's viewed across the river from point N. Okay, so there it is here. So there is the tree and the stake, right there from point N. And then it gives us some other stuff. And what we want to know is we can use this based on the property of triangles, similarity in this case, because if you look at these triangles, they're not the same size, but do they have the same angles? Well, we'll find out in a sec. We can actually use that to find out what the length of X is. Okay. And this comes back to the unit we did, remember, on proportions? Remember I had the picture of the flagpole and the length of the shadow and the person and the length of the shadow. Do you remember that example? We did it quite a few chapters before. But in this case, we can use it. So what happens is we got to figure out if these triangles are similar. Let's check to see if they are congruent angles. Okay, angle K and angle M, are they the same?
Yes.
Okay. Well, does it tell us here? We don't know anything else about this, but what it can be is, do they have a common scale factor? Well, okay, sorry. I just screwed that up. I apologize. Let me fix that. Angle K and angle M are exactly the same, so they are congruent. What about angle L and angle L? And what I'm talking about is these 2 angles here. This angle L, like TLK, right, and MLN. Are they congruent?
Yes.
Why?
Are they
Because
complementary
there's a
angles?
rule.
No, they're not complementary angles because they don't add up to 90. They're, Alice, I think you said it. No.
There's a certain rule.
Yeah, it was the rule. Do you guys remember that? Do you remember when we had the 2
Opposite
parallel lines and we
rule.
had the line that cut it? Angles on opposite sides were equal to that. Do you remember that rule?
Yes, but I don't know what it's called.
I forget what it was. No, okay, now you're gonna make me try to remember what it was called. Some of you are thinking, you're the teacher, you're supposed to know this. Yeah, don't ever let that fool you. Sometimes you forget things. Do you remember what chapter that was?
I think chapter 9.
That's 8. This is 9. They were called, there it is right there, vertical angles. Look at that. I'll even hold it up. You might not be able to see it. Right at the top there, vertical angles. You were right. You're right. Okay, so vertical angles and chapter 9. So wow, that's it. You're taking over the course. Okay. So those ones are the same, then they're vertical angles. Now, by default, then, what does that mean about angle T and angle N? Angle T and angle N,
They have to be the same.
they have to be the same. They have to be congruent, right? If we got three angles that are congruent to three other angles, those triangles are similar. That's it. That's the rule. If you have the three angles that are side. Now, we obviously know that the lengths aren't the same. We can see that. They could be the same. They could not be the same. It makes no difference. Our only stipulation for similar triangles is the angles have to correspond to each other. Okay, now, here's the cool thing. So what we can do is we can set this up as a formula. Okay, so here's the, just ignore this top part because it'll make sense here. Here's the formula. X over 30 equals 125 over 50. So let's look at the picture again. X over 30, right? So X over 30, because those ones are the same for each other. X over 30 equals 125 over 50, right? X over 30 equals 125 over 50. Now, cool thing about this is you could really screw this formula up and it'll still work. For instance, if you did X over 125 and 30 over 50, it will also work because there's still a pattern there. But this one we're working on right here is X over 30 equal to 125 over 50. Now, if we look at that, that's a proportion, right? And how do we solve a proportion? We cross multiply, right? So it's going to be 30 times 125. Yeah, there it is there, divided by 50. So then we can find that the other side is 75. What's that little tick mark mean, by the way?
Prime.
Prime.
It would be prime if we were doing the rigid stuff that we did yesterday. In this case, it's the abbreviation for feet or foot, right? Yeah. Isn't it annoying that symbols we use all the time are used different ways within math, right? And it's kind of, no wonder kids have difficult time with this, right? Because if yesterday we were dealing everything with prime, but this is 75 feet.
It's like, it's the font too. Like sometimes the font completely changes the way that it looks.
You are correct 100%. And that's a big thing, especially when you guys be working on teaching, especially when you're using the variable X and you're using multiply, right? Sometimes the font will really change what it looks like. So you're gonna have to be careful of that. Okay. Now, we did two properties with congruent triangles, right? Now just go, I'm going to flip back real quick. Here's the properties here. This first one was side, 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 right? But these triangles were, they were congruent, correct? All the sides, all the angles were the same, right? And then we did, what was the next one? Side, 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 angle, side. Okay. That also works for similarity. So these next one, hang on, let me get to it again. It's the problem when I got to go so far back. If the three sides of one triangle are proportional, that doesn't mean the same length. I'm talking about proportional to the three sides of another triangle. We say that the triangles are similar. So now if you look, you see the lines here, how they did the red ones and the blue ones and the green ones? Instead of just a straight line, they do them wavy, which means they are proportional. So for instance, CB and FE, FE might be twice as large. That's a proportion, right? So look at what we got here. DE divided by AB, whatever it is. So let's say it's 4 divided by 2, so a scale factor of 2. Is equal to EF over BC, which is equal to DF over AC. If you do that, if you take this side this side divided by this side, and this side divided by this side, and this side divided by this side, and you get all the same number, you can say that their triangles are similar based on the side, side, side property, right? And if you look, you see how we use the one little squiggle here? Because that's similar, right? We don't, the side lengths are obviously different, but they have the same proportion, which means it could be twice as large or twice as small or 10 times as large, right? And it's a really neat concept when you're doing this because it has to do with that scale factor we were talking about yesterday, right? You basically take any measurement over on the second figure divided by any measurement on the first figure. And if you get the same number for all three of them, there's your scale factor, right? It's kind of a neat concept. That was side, 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 and that side angle side also applies to similarity. Okay, so if you have two sides are the same, so in this case, DE and AB, and sorry, if they have a similar proportion, right? It could be twice as large or 3 times as large or smaller, and you have an angle between them, and then you have proportions here, right? DF and AC, and those proportions have to be the same, right? You can't have like a proportion of 2 and a proportion of 1.5. Then it doesn't work. The proportions have to be identical. Okay, so if you look what we got here, the proportions are equal to each other. Angle A is congruent to angle D, which means it's the same. Then we can say triangle ABC is similar to triangle DEF. Okay. It's one of those things, right? These triangles are similar, right? But you could also have two identical triangles are both way back at the beginning, right? Let me just go to this one that we just did, right? These ones here is congruent, but they also are similar, right? Because they are exactly the same. So there's some neat options on this one. Where were we here? From current slide. Oops. Okay. So like I said, that is the end of 12, sorry. 12 is a short lesson. In fact, let me just double check. I think the next few lessons are quite a bit shorter, just to kind of give your brain a break from what we've done. So we did some of the harder stuff at the beginning. Yeah, that's a shorter one. The next 13 is a shorter one. 14, oh, actually, that's it. We only have 2 more lessons after that. Wait, is that 12? We only have 2 more lessons, by the way. We only have 13 and 14. That's it. Can you guys see the light at the end of the tunnel? Might be a train coming towards you, but.
Excuse me, Brian.
Yes.
Is it okay? I won't be able to attend class right now. I have to take my sister to the nursing station. And she's
Yeah,
pregnant.
no problem. Just watch the video tomorrow then if you get a chance, please.
Okay, thank you.
You're welcome. And I saw your message there too. I just read it. So
Yeah, okay.
okay. So sorry, that's let me get back here. Oh, so if you look at what you got for exercises, and we got lots of time, but that'll give us more time to play some of the games at near the end of class, because I want to show you how many games was it? I think it's four things I want to show you at the end of class. So this one, there's less lesson, a little bit of practice, but there's more stuff at the end of it, which is, I think, more entertaining anyways, and more practical applications. So there you can see on the board, or sorry, on the thing, 12.1 to 12.3. Don't do any of the ones from 12.2 because that's all about construction. I'm not caring about that. So 12.1. What is it? 12.1, 626. Take a look here. Yeah, these are just about corresponding vertices, corresponding sides, using the theorems, which one's side, 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 side angle, side. That's the 626 one. And 654 is which triangles are similar. So you have to look at the rules. Yeah. Yeah, those are pretty. So we'll work on that. What time is it? 5 to 6. What do you want, half an hour? And within that time, you can take a break in there too. Do you want, or do you want half an hour and then take a break, or? It's up to you. Anyways, let's start with half an hour. So let's go from 6:30 or till 6:30. And then we can evaluate what we want to do after that. Okay.
Why did you say there's no practice questions for 12.2?
Because that's the one on construction.
Okay.
So there's no reason to really cover it because I'm not going to ask, for instance, I'm not going to ask you to do that on the test or anything like that. So if you look, if you actually turn to 12 point here, I'll give you the page if you want to see it. 643, right? It says use a straight edge and a compass, right? Use a straight edge and a compass. right? So it's actually getting you to physically get the tools to use, which most of you probably don't have with you anyways, right? So it's not really that valuable to us.
Brian, I had 2 questions for you.
Lacey,
Yes. One being, I realized I made a mistake on the assignment. Could you delete?
you lost half of, that was your only half a mark you lost.
But I know what I did wrong. Can I fix it?
Yeah,
Like
I guess I haven't sent it back to you.
Yeah. So could I fix it and send it to you
Yeah,
tomorrow?
I knew I was marking it, and I'm like, oh yeah, I'm marking it. Oh yeah, and I got to that, and I'm like, oh crap, she's gonna be mad because she waited one day, you wouldn't have got it wrong. Yeah, fix that one question.
Perfect. You know what? I got it right at first, but then I questioned myself after class yesterday, and I kind of like readjusted it, and then now I realized
It's really a tricky thing, right? It's if you go back to polygons, it comes back to the same property. Is a square a rectangle, or is a rectangle a square? And it comes back to those properties. It's all in the nuances of the wording, right? It's the same with that question.
Yeah.
Yeah, fix that one. Yeah, I won't send them back till Friday anyways, right? So nobody will have seen it. So
okay, well, I will just change that one question.
yeah, just do the one question and scan that one page, please.
Okay, perfect. Thank you very much. I appreciate
welcome.
it. My other question was about the learning activity, because I was looking at it.
Yep.
And it says that you want us to do like a cross-curricular.
If you can, it would be preferred if you can. Let me put it back up here.
Okay.
Like, what are you teaching right now?
French.
Do it. Do math and French.
Okay, sure.
So something, and this is just, I'm spitballing here. So if you're teaching French and you're teaching math, you could teach how to count to 20 in English and in French, but you could also show it pictorially, right? Or you could use a manipulative to do it however you want.
Well, because I was planning to do the I have, who has thing.
Dude, that's a great one. That's one of the best ones out there. I still do that in high school.
Well, because you can use it for so many different
I love it. too.
applications, like fractions and multiplication, division, addition. It's a lot of like mental math facts.
Yeah,
So
that
I
works.
wanted
So
to do
yeah, that
that.
works. So who also said Alice? So for instance, if you want to do that same activity, just do it with math and some other subject.
I teach a lot of science. Should I just integrate science?
Perfect. That would be a good one too. Math and science. I mean, who teaches German on the colony?
Hmm.
You do
Two
too?
other men.
Okay, so you could do German and math if you wanted to too. But you pick what you want. It's up to you. It's your activity.
Okay, so I could just do that activity, but in French.
You got it.
Super. But would you like me to still do the report in English, or?
Yeah, my French is rusty.
I
I only took 7 years of it, so
okay.
I think
Great,
my Spanish
thanks.
is getting better than my French now.
Ah, good. That's great. I also speak Spanish. So.
Oh, there you go.
Awesome. Thank you very much. That was
You're
I
welcome.
wanted to get started on that this week. So
Yeah, it's and again, look at right here. 1 page max. Do
Mhm.
not write me essays. I
don't
want
use the
simple
word.
to the point stuff, right?
Great.
The biggest thing probably will be the directions, right? And that's really an easy direction, right? Of how you distribute it to the students, right? And then who starts, right? That's the key thing.
Exactly. Awesome. Thank you very much. That's perfect.
You're welcome.
Great.
Can I just ask a couple quick questions about assignment 5?
Yeah. Give me 1 sec, Nicole. Let me just put this in the right spot.
No worries.
Hang on. Assignment 5, which is right here. Okay, go ahead.
Right. Question number 2.
Okay.
I'm just curious when it's saying asking round your answer to the nearest 10th, is it 10th decimal or 10th place? That I was just
10th place. So that's like 1 spot to the right of the decimal.
okay. I just wanted to
And
make sure.
again, I'm going to have different answers because I said yesterday, right? Some people can use 3.14 if they want, and some people can use the pi button. I have both answers. It's not a big deal.
Okay.
Make sure on that one that if you notice, they give you the diameter, right?
Yeah, I caught on that.
You got to make sure you
Yeah.
change that first to something else.
Yes.
Okay, good.
Is tenth nearest tenth like 36.42?
No, that would be hundredths,
Okay.
right? It's tenths is one spot to the right of the decimal.
Question 18 as well, when they're asking to find PQ, is it is it the angles or is it the length of the side that
No,
they're
when they give
asking?
you PQ, it would be an angle if they give you 3 letters, right? So for instance, if it was ABC, that would be angle B because that's the one in the middle, right? Or you would just say angle B. But when they give you just 2 letters like that and they're capitals, that's just the length of the side.
Okay. Okay. And then, oh, the last one was just scale factor when we did that yesterday, right? Or was
Correct.
that?
And
Okay.
on 23, don't change it to a decimal, just leave it as a fraction.
Leave it as a fraction. Okay. All right. That's everything. Thank you.
You're welcome. Oh, I should double check attendance here. Who joined us? Denise Meaches. Do I see Denise anywhere? No, I do not see Denise. Kayla George, are you here, Kayla George? Let's look. Nope. I know Olivia is not going to be here, and Holly was going to be late. Did she come yet, Holly? Or did she was I talking to her? I can't remember. Holly Baptiste is not here yet. Okay.
I have a question about number 11 on the practice questions.
On page 627.
Yes.
Okay, go ahead.
So question 11. What do they mean by CBD by SAS? What is SAS?
Side angle side.
Oh, okay.
So right, so what it is BD, there's your first side, right? Angle D, which is the 90 degrees, and then either DA or DC, right? That's your
Mhm.
side angle side.
Yeah. Okay.
Brian,
Yes, Alice.
for question 12 on page 627,
Right?
is it angle side angle?
Yeah, because what it is those triangles form that central line. So that's the one that's the same for both. So it's either that AD and then angle D. So it's angle side angle. Either way you look at it. Correct.
Okay, thanks.
You're welcome.
For question 12C, is it angle side or side angle side?
Hang on.
Mm,
Yeah, it's got to be angle side in that case, right? From A to C and then that
Yeah.
CB, right? So that's, you
okay.
just gotta, they have to be kind of in a row, right? So you can't go like CB and then jump all the way over to angle A and then C, right? It has to be kind of one after each other.
Okay.
Oh, Holly. Holly, you're here now. We're just doing, well, you can see on the screen, we're just doing some of the exercises here. So the lesson that you missed, you could probably just listen to it tomorrow if you want, once I post the video.
Okay, what
Thank
time
you
does
for-
the video usually post about?
In the morning sometime, usually when I get here, I let it render overnight or do whatever it has to do. And I usually put it up by 9 o'clock usually.
Okay.
What about question F, Brian?
Question what, sorry?
Question 12F.
12F? Angle. All angles in this case. One just happens to be flipped, but it's still angle, angle, angle.
Brian, can you help me with question 37?
In the book?
Yes.
Oh, okay.
Does it
Go ahead.
does it ask me to prove that that it's twice the angle AOB?
Yeah, I don't know if you remember this. This was one of the ones you did if you took a high school, you did circle geometry. A central angle, right, that goes to the center. So for instance, BOA, right, BOA, right, is twice BPA. Okay, inscribed angle, central angle. It has to do with that. So they want you, what do they want you to do here? Yeah, there's really no proof with that one. I shouldn't have probably put, well, I can put that in there. Basically, what you have to remember is angle, that angle is twice the other angle.
Yes,
That's all it is. And we, back even in high school, we never showed it as a proof. You just showed it as a rule is what it was, right? So for instance, if I said angle BPA was 40, right? You know, well, that's a bad example. Let's say it was 60, BPA was 60, then you know that BOA is 120. It's just the rule that you remember.
Okay.
Those questions there, like anything past like the basic questions that I would ever give you are like the first 1 to 10, something like that. And then as you go through the book, you get like critical thinking ones. And this is one's called making connections. So this would have been making a connection to something you did a long time ago. That's all it is. Those questions, the higher end ones.
Okay, thanks.
You have to do that when you're teaching, right? You give 75% of the kids do this stuff, and then you give a few more to try the higher end stuff, just to keep them engaged, right?
Makes sense.
Like, I wonder if do you remember your rules for 38 and 39 also? Do you remember those rules? .38 is actually identical to the rule we just did. An inscribed angle, a central angle is twice the inscribed angle. Same rule.
The second question makes 39 is just the diagram is similar.
It is, and all you got to
Yeah.
remember is that's an inscribed quadrilateral. You just got to remember your rules about which angles are which angles, right?
Hmm.
And it's opposite angles. A and C are 180, right? And D and B are 180. That's the inscribed quadrilateral rule of circle geometry.
I always like those
Some
beyond.
people like circle geometry, and some people absolutely hate it.
I really like any triangle, an angle squash.
You got to teach it then.
I hope to.
I'll be back in a second. Just gonna fill up my water bottle.
How do we find scale factor?
Sorry, what was that?
How do we find scale factors for question 12, 1A on page 654?
1A. Well, you
Mhm.
take the second image. Okay, so first off, angle O corresponds to angle C, right? Angle N corresponds to angle B. So then the 12 on the bigger one corresponds to side 8. So any scale factor, you take the measurement from the second one and divide it by the measurement in the first one.
Well, there's only 2 and they're the wrong ones.
No, they're not the wrong ones. The triangle needs to be spun around. Those are the correct ones. Those are both the hypotenuse.
Oh, okay. Will it be the same scale factor for every side, all 3 sides, I guess?
They would have to be in this case, yeah, but they just want to know the scale factor, right? So 12 divided by 8, right, which is 3 over 2, so it's 1.5, right? The scale factor is 1.5.
Okay.
Can I clarify? Is it often that the angle and the vertices are the same?
Yeah, if you remember what vertice was when we talked about nets, vertices are the corner points, right? So if you have a 3D image, the vertice is just the corner, which is an angle, right? The difference is it's in 2 dimensions, right? When those other ones were in 3 dimensions, that was the only difference.
So for example, in like the first question there, A and C would be the same answers.
And on 12.3?
12.1.
Oh, sorry. I was on 12.3 because I was just helping Alice.
No, that's
Hang on,
okay. I'm ahead, but now I'm questioning myself.
Hang on. Let me go back here. What page? 626. That would help if I actually looked at the page. 626. Yeah. Basically, it's the angles, right?
Okay, cool. I just was wondering if I totally missed something.
No, that's just another way to say it. And what the little arrow is L corresponds to, what is it? K? Yeah, L corresponds to K.
Yeah.
Yeah.
Okay, great.
Brian, I need help with question 5 on 655.
Give me one
Why-
sec.
wha-
Hang on, give me 1 sec. Sorry. Question, which one? Sorry.
Question 5A.
Okay. Okay. Well, you set this up as a ratio, right? So there's many ways to do it. 12 divided by 5 equals 8 divided by A, right? That's one way of setting it up.
12 divided by 5 or 12
Sorry,
divided
12 divided by
50?
15 equals 8 divided by A. I meant 15. when I
Why
said-
not 15 over 12? Does it
Okay,
matter?
15 over 12 equals A over 8. It makes no difference,
Okay.
but the pattern, you have to have the consistent pattern, right?
Okay.
So 15 over 12 equals A over 8. You could also do, and just I'll throw it out there, you could do 12 over 8 equals 15 over A. That will still work. As long as you follow a pattern, no matter how you put it, it will work.
Okay, thanks.
I think most people are working away here. I'll give you a few more minutes to work then on it. It's better that I give you time. Then if you have questions, you can ask. We got lots of time anyway, so.
I do have another question. What does the little M in front of stuff mean?
Oh, you're on 12.1 again. Hang on.
Yeah, I
Sorry.
fixed that question before I forgot and sent it to you first.
Oh, the measure of angle L.
Ah, okay, so it would just be
Whatever. You
56.
could just write angle L.
Okay.
There's lots of variations when they write stuff like that, right?
Okay. That's weird. They shouldn't do that.
They do it all the time. Well, for instance, sometimes like if you look at question 3, let's say, you could either say angle A or angle BAC or
Yeah.
angle CAB. All three of them mean the exact same thing. They're all angle A,
It's just trying to confuse people.
pretty much.
Can I quickly ask how to do question 6A?
Sorry, what was that?
Will you help me with 6A? I'm confused.
On 12.3?
Yeah.
Okay. C over 15. So this one's a little bit trickier because if you separate the triangles, right? The smaller triangle is going to be C and 15, correct?
Yeah.
The larger triangle, if you actually broke it apart and draw out another triangle, the bottom part's going to be 18 and the top part's going to be C plus 2. So you can actually set up a proportion that way. So you could set up, here, let me write this down here so I don't forget. C over 15 equals C plus 2 over 18. Okay. So here you can look in the picture. I have it. If you can see the screen, I'll just do it. I did it on a little, it's going to look like that, right?
Okay.
Then you can actually cross multiply and solve. It's a little trickier because you have to collect like terms, but you can still do it. So. I think we can probably move on to some of the activities. I think that's a lot of time that's normal, way more than I normally give you to work on stuff, which is kind of nice, I think, for some of you. Gives you a chance to do some of it and work on the assignment too. It's good because the test is tomorrow. So 50 questions again, just like normal. Make sure you have your formula sheets printed off and ready to go for tomorrow. Printed off is way easier because then you're not fooling around looking for it. All right. Sorry, my laptop decided, my Brandon School Division laptop here decided to download everything and restart itself. So I'm just getting back in so I can see what you guys are looking at, make sure.
So are you going to teach us how to play cribbage?
No, you know how to play. Most people know how to play cribbage. I want to talk to you why it's relatable to math. Same with.
I've completely forgotten.
Sorry, what was that again?
I used to know like 10 years ago or something, but I had no idea.
Yeah, it has to do with getting sets of 15 and runs and pegging in on the board. We can talk about it if you want. Okay, there, now that's better. Now that's going up. Okay, the first thing I want to show you though, and let's go back to this page here. I've put on here a couple, where are we? Day 18, Tuesday. Wow, June 1st. I can't believe it's June already. Okay, so there's 4 things I want to talk about. I want to talk to you about set. What set is, and I'll hold it up in the camera. Basically, you buy it. Setgame.com, Amazon sells these things. They're about 15 bucks. I've given these to so many people as gifts because they are just incredibly fun. And what it is, it's a bunch of cards. And so you get the thing here and you get decks, you get these cards in it, right? For those that are watching the video, it's just a bunch of cards. And what it is it's a game of pattern recognition. And the really cool thing about this is I've had kids that really suck at math are able to play this game because their brains work differently. And what it is there was a lady out there, she was an engineer and she was part of Mensa. And I don't know if you know what Mensa is. Mensa is the really smart club. In fact, they just had somebody join Mensa in the US, a 2-year-old just joined Mensa. Anyways, this lady, she created this game. And it says here over 25 best game awards. Yeah, this thing has received tons of awards. And what it is, it's patterns on it. So there is different colors, there's different symbols, there's different shading, and there's different numbers. And what kids are looking for is they're looking for any one of those patterns. And it has to be all or nothing. So they either have to be all the same color or all different colors, right? Hang on, what's Callie saying? You can mail each one. Yeah, not happening. Yeah. Yeah, set. So here's the cool
That
thing.
reminds me of FaceTime.
Yeah, there's an online version of this every day. So it's one of these games you're probably gonna just bookmark on your computer and look at it every day. So let's go to one. Here's the daily game. It'll take us there. And what it is this is, yeah, Tuesday. Whoop, hang on. The page is all, oh, yeah, we use cookies. Yes, I agree. Take a hike. There we go. Okay, so here's the game here. And you can see there's all different shapes, colors, right? So there's red, greens, and purples. There is diamonds. I call these packing peanuts or squiggles. I don't know, and ovals. Then there's fills. This one's open. This one's striped. This one's solid. And then there's different numbers, 1, 2, and 3. And what you're looking for is you're looking for those 4 attributes: color, shape, fill, and number. And the attributes either have to be all the same or all different. And what this one is you get to pick which ones you think are sets, and they'll throw it along the side. It's a daily puzzle. Okay. So for instance, I see one right away, and I'll put it up here first. So look, I'm going to click on the squiggle, the diamond, and the oval. Okay, so here it is. The color, they're all the same. That attribute works. They could either be all the same or all different. The number, they all have 1. So either all the same or all different. This one, the fill is empty, all the same or all different. And this one, the shapes are all different. So that attribute is all different. Okay. Can anybody think they see what, and when you're playing this with kids, the best way to teach this is by them making mistakes, because they'll make a mistake and you'll show them why it's a set or why it's not a set, right? And then they can move on. And some kids pick up on it really quick, and some kids will be able to teach other kids. Okay. So look at this one. Can anybody look up, if you're looking at my screen, I'll let you go to the website in a sec, but can anybody go look at my screen there and see what they think is another set?
The sets of 3.
Sorry, say that again.
The sets of 3.
There's a whole bunch of 3s. Which ones? Right, there's 4 3s here. I see them all here.
Oh, I messed them on. Can we do all 4?
Can you do what? Sorry?
Can we do all 4?
4 of them? No, 3. See, if you look on the right-hand side, right, there's 3 columns. That's what you're trying to fill.
Well, the ones that are outlined, the 3 outlined.
Oh, so the purple oval, the red diamond, and the green oval. Okay,
Yes.
let's try this and watch. Nope, that's not a set, because 2 are ovals and 1 is a diamond. Either this diamond would have to be an oval, or one of these other ones would have to be a squiggle. Okay, I'll put another one up there for you guys to see. Solid diamond, 2 lined squiggles, and 3 open ovals. Okay, so in this case, they're all green, but the other attributes, all different numbers, all different shapes, all different fills. Okay, so that's another option there.
Could you do the solid diamond, the 2 red blank diamonds, and the 3 purple stripy diamonds?
Well, look at that. There is a set that was found. Now, in this case, the diamond is the only thing that's similar, right? So all diamonds, but all different numbers, all different colors, all different fills. Now, the hardest one to find is all 4 attributes are different. And so I had one kid, oh my goodness. I can't remember, what was his name? Picture's up on the wall in my classroom, I can't remember. Anyways, oh, Mark Yance, that's what it was. It was when I taught at Vincent Massey, his name was Mark Yance. He could pick these out like that. It was amazing, and he sucked at math. He absolutely sucked at math. But he was able to pick the ones that are completely different. All four attributes are different. So maybe one of you can pick it out. Let's see. If there is one.
I see one.
Okay, tell me what it is.
It's like the green cylinder, round oval pill.
This one here at the
looking thing.
bottom?
Yeah, yeah, and then the one right above it, and then the 3 diamonds.
Okay,
3 red diamonds.
so this one, right? All different shapes, all different numbers, all different colors, and the only thing that's the same is they're all open. Correct. The nice thing about this is it'll tell you whether or not it's a set or not. So it's a good learning thing too, right? And you can play this every day, every day, every day, and it's free.
So it's an online game and a card game.
The card game is, you can buy it like this, right? And then all you do is you put the cards down, face down, and then you have the kids sitting around it and they look at it and then they have to say set, and then they grab the 3 cards. Now, here's the deal. You play it just like that way to learn it, but then when you actually get playing it, if they say set and get a set, they get a point. If they say set and it's wrong, they lose a point. So it gets really competitive. So here's some background story. I was a foreign currency broker long before I was a teacher, right? I bought and sell foreign currency on the open market. And we had a staff party one time. And somebody had this at the staff party. So of course, it's a staff party. I'm having a few drinks, right? You know, having a really good time having a few drinks. And we started playing this game. And I had so much fun playing that game. I went out the next day and bought it. This is before I was even a teacher. And now I've given it to people that I know that became teachers. I gave it to all my nephews and nieces. They all have a copy of this. That and Settlers of Catan, if you ever play that game. I gave them copies of that. So
Love that game.
it's great. You really got to get into it, right?
It's very popular here as well.
Yeah. Okay. So if you want, I think Sam messaged that he had trouble getting into it. Let's just check. Did any of you try to get into it yourself?
Yeah, it works for me.
Okay. So if you go there, it should be, if you click on the daily game, like on my website, it should open up. And you can actually, if you get playing it, you can do weekly winners because you can submit all your stuff and you can like register and submit all your stuff. It's kind of fun. But if anything of today, please use that game. I have kids that have come to, like when we had regular school, not this COVID stuff now. I've had regular kids come and knock on my classroom door and ask to borrow the game to take to another math class because they wanted to play it in that class. You got to trust me. It's just an awesome, awesome game. Okay, so some of the other things I wanted to show you is in my classroom here, and if you look at the camera, let me take the camera here for a sec. I'll point it at the back of my classroom. Where's my classroom? There it is. So at the back of the classroom, besides all the Simpsons posters, I have a ton of board games back there. Because in math, board games are really good ways of teaching, like Monopoly. I have probably 6 or 7 Monopoly games. The other game I have 3 or 4 copies of is Yahtzee. Yahtzee for kids learning to count is an amazing game. Because you think about it, when you're rolling Yahtzee, you have to go for, well, here's Yahtzee score sheets, and I have these. So for instance, you don't even need the game Yahtzee. You just need 5 dice and one of these score sheets. So what happens is, you remember if you're rolling for 1s, 2s, 3s, and 4s, 3 of a kind, 4 of a kind. And what it is it makes them add up things really quickly. Oh, 3 of a kind. I got a 3, 4, and a 5. Bang, and they add it up really quickly. Okay. That's funny. I think that's Lori again on the iPhone. You can get them to count really, really quickly, and you can get them to add without calculators. It's an amazing game to help kids build confidence in multiplication and counting, right? So for instance, here, you roll 4 5s. Well, you could count them. 5 and 5 is 10, or then you could go, oh, I got 4 5s. 4 times 5 is 20, right? So it's a good way to show them multiplication or skip counting, something like that. So again, if you were in class if we were all together, we would play the game. And people love this chapter that we're on because it's a lot of games for the activities. But if you want to, take a minute, and there's lots of websites out there, and I've included one on here. So Yahtzee score sheets if you're playing. And then if you want to, there's a link to a Yahtzee game. And it's nice. You can roll the dice, right? So here, we'll roll the dice. Pick the ones we, oh, wait here. Oh, Bill and you, did I just screw up? Oh, hang on, let me restart this, sorry. Okay, here we go. So roll dice, here we go. Oh, it's giving you the different options. I'm gonna go with the 3 6s because that's my best option there. Roll the dice, nothing yet. Roll the dice, nothing. And then select your move by clicking on the cell on the scorecard. So I'm gonna click on my 6s and then you can play it. Okay, Bill's turn. You can watch Bill play. In fact, some of you probably have a Yahtzee game on your phone right now. I know I do. It's one of those ones when you're trying to kill time. It's a great game to play.
I have settlers, but not Yahtzee.
Oh, do you? So again, what are we doing now? Let's do 5s, right? Pick 5s. Oh, why did I do that? Let's get rid of that and pick 3, 4, 5. So that's a small straight, right? And if I get a 2, nope. So then I'm picking my small straight. There it is. Okay, so if you want, you can take a couple minutes and play the game or do this whenever you want. I mean, some of you have probably been playing it while I've been teaching. No big deal, I don't mind. I'm just joking with you. But again, especially if you're going to online learning, right? You could talk about addition and multiplication and then get the kid, you'd have to explain it, get the kids to play Yahtzee. It'll help them build some of that skills, right? So that's Yahtzee. The other one, cribbage, right? I think Eric was talking about cribbage, right? And again, it's the same company, Card Games IO, right? So you can talk about, you can do cribbage. Cribbage is another good counting game, right? Because you're like 15-2, 15-4, 15-6, right? A run is 3, right? You can do a lot of weird addition in your head, like chunking addition. And then it also gets them to count on the board. Some of the kids are going to count like by individual holes, 1, 2, 3, 4, 5. And then some of them realize, hey, these are in blocks of 5. So if I have to do 12, I can go 5, 5, and 2, right? They can get that faster variation on that. Okay. And again, you can play this, pick a card to decide who does. So I'm the dealer. There we go. Right. Remember, you got to put 2 cards in my crib. So what am I going to put in? Ooh, I got garbage in there. I'll put in the jack and the king. Send a crib. Right. And you can play the game. So this is good practice in what are you wanting to do, right? So there's my pair of 2 for 18, 21, 29, unless he has a 2, he'll say go. Yeah, there's my ace, 1 for last card, right? You can figure out, and I think they give you the rules on this. Yeah, cribbage rules, here's all the rules. So Eric, if you can't remember, right, you can just quickly kind of glance at those cribbage rules. Another one that's really popular, and I didn't put on here, what's it called again? I think it's called 10,000. Is that right? It's the one with the dice. Does anybody remember?
Zilch?
Is that the one? It's the one where you roll the dice and you're looking for pairs of 5s and, is that, no, what is it again?
It's called Zilch.
But you go, like you count up to 10,000, right?
Yeah, you roll over and over again until you get zilch, and then you lose all the points if you did not stop rolling.
That's right. Okay, yeah, I think there's a bunch of different names for it. It's 10,000 or zilch or things like that. But it's a really good one for kids to play. Like if you can play games with your kids, because all kids like to play games, right? And I'm not talking about lots of video games. Like, I mean, we're looking at this because we're remote learning, but if you can get them to play games in class, you can get them to add and multiply really quickly without even knowing it, right? You got to fool them. You got to trick them into learning. Okay.
It's a nice way of learning.
It is a nice way of learning, right? It's wonderful. Actually, one of my best, and we used to have time to do this, but again, we don't have time. One of the best things you can get your kids to do, especially if you have early and middle years, is to get them to create their own board game. It's actually a wonderful concept, whether it's simple like snakes and ladders or a simple path around a thing, and they can make cards, and you can get them to, pick a card and it says 6 times 7, and you got to do it really quickly, or you get to move forward, and if not, you get to move back, right? So you can get them to teach multiplication with a board game. But if you get them to create their own game, yeah, that's actually one of the things I've done in high school too for Essentials, Callie. I've got them to create board games. Now in high school, they do a little more creative games, right? In fact, one of the guys I went to university with at Brandon University, you might have seen him in your school division. He's the guy that came up with Mathopoly. His name is Willie Penner. You guys ever seen the game Mathopoly? You guys know what I'm talking about?
I think we have it in the school, but I don't know how to play it.
It's the guy I went to university with. He was bored one day and he decided, he was a math teacher, decided to come up and create this game. And now he's been promoting it around Canada ever since. He's not a millionaire or anything, but I mean, he just saw something he really liked to do and made a game out of it. So, oh, there, Eric just finished the game. Nice. You got all the, how many was there, Eric? Was there 6 or 7? I can't remember.
6. There was
6, okay.
6.
So now you can submit it online. Okay. The last thing I wanted to talk about is what we were talking about yesterday, the tessellation stuff. So this is a really cool stuff. And again, this website's not going anywhere. So for the next, well, as long as I'm alive, the next however many years, 2, 3, who knows, maybe 10, 15, who knows. This site will be up here. So if you want, take these links, take any of this stuff and use it. So we were talking about the Tessellation Project yesterday. So this is a really nice way to teach kids how to do it. Tells you the materials needed, blah, blah, blah. This is a really cool, simple one. So you take a Post-it note. Post-it notes are nice and square already, perfect squares, right? And you can get different sizes. So this one, you just follow the instructions, draw from corner to corner, cut it out, right? And then tape it to the other side. So you can see you get this really weird looking pattern here. And then what you do is you just draw around it, draw around it. What often I get kids to do is once they make their little template, I get them to glue it to a piece of manila tag or cardboard, something to make a nice heavy duty template or pattern, right? Then it makes it easier to draw and draw. And then you can see, this is just a simple one. You draw it and then you can get them to color it and you get amazing patterns. And again, it's that rigid motion from yesterday we were talking about, right? Slide and you can do other ones. This nice, easy steps for you guys to follow. You could print that out in color, give it to your kids. So if they're away, they can do it. By all means, try this. Even we still got another month if some of you are teaching in the school still. Give them a Tessellation project. They're going to love it. Now, if you want to take a look at this, there are 2 videos that I attached to this. And these are, hang on, did they go to YouTube? Yeah, these 2 go to YouTube. Oh, hang on, we got commercials. Okay, so this one goes through and you can see exactly all the steps. This one's doing something slightly different. Okay. And again, there's sound with it. You can watch it. This one's going to look beautiful. Look at that. That's a basic pattern, right? On a perfect square. Cut it out. There, let's move forward. We don't need to cut it and rotate it, right? So you cut it, rotate it, and then tape it together. Cut out the next piece, right? These are guide by guide instructions, right? I don't want you to have to create anything new, but try tessellations. They are so much fun. And there it is, rotate it around. So this is a different tessellation, right? This is rotational tessellation and then a slide tessellation.
I can see my students having fun.
Oh my goodness. And here's the thing about this, right? A lot of students, it's a scale, right? You got weak students, you got strong students, right? Your strong students can do the really, really amazing, intricate patterns, but the weaker kids can also do simple patterns, right? I showed you some of those examples yesterday, right? So there is a starting point for all levels of student. So here you can see them. So now there it is there, and now you rotate it around. This is rotational tessellations. It's amazing. Here, let's fast forward a bit here. And this person's doing it really quickly. They're not being too exact. Some of your kids will be amazingly exact, right? So there's rotational symmetry. Beautiful. Keep going. I'm just flipping through this video pretty quick. So there you get a whole page of tessellations. So that is rotational style, right? And the other one I'm including on here is mirror tessellation. This one's really cool too. Let me show you this one. Oh, we're gonna have ads again, sorry. Oh, maybe not. Oh, this guy's gonna talk. Oh, it's got music. This is useful. when you're doing flip rotations, you color one side of it because then you know exactly what side you're looking at when you flipped it. I tell you, the YouTube and the internet has done wonders for education. It's also killed a lot of education, but we won't go. So this one, well, here they're cutting it. I'll let them cut it out. Let them cut it out. Then, see, place and tape. So you flip it, yeah, and then you put it there. Tape it to the bottom, and you flip the other one. So it's a different type of tessellation. But again, here, we'll wait till they. Okay, and then they're going to tape it. So let's see what this pattern looks like. So it's a big shape, right? Now you have to flip it to do the next one. So you keep flipping it and trace, flip and trace, flip. And look at this. That's a big pattern, but it looks so complex, but it's pretty simple. So. There, let's go to the end and see what it looks like. Oh, this person decided, this person must be an artist, right? So they're drawing faces in on all the different ones. Oh, you can be so creative with it. So
That's even an art project.
it's an art, but here's the thing about it. The whole basis of it is math, 100% math. So you can make that connection to whatever you're doing it in art or in anything and bring it back to math. If you can make that connection, kids are going to love it. Okay. God, I talked a lot today. Oh my goodness, I talked too much. Okay, so here's what I want to just highlight. I'll stay on for a while if you have questions about the assignment. Reminder, the test is tomorrow. And you can see right there, day 19, Wednesday, June 2nd, test, chapters 10, 11, and 12, the stuff we've covered, right? Make sure you have your formula sheet in front of you because there's some questions on area and volume, and there's some questions on, for instance, inches to feet, right? Or meters, centimeters to meters, which are on those sheet also, right? So keep that in front of you. Have your calculator, have your scrap paper, all that and ready to go. Okay. So if anything, what I want you to take from today, and this is nice one, Justin. I want you to take from today, set the game set. Do me a favor, save up your pennies and your nickels and your dimes, whatever. It's about 15 bucks, right? Buy it. First thing you do for next year, September, buy that game, get it. It is so useful. In fact, I have, I think, 4 different copies of it here because I just keep buying them when I see them. Try to play more games. 3 things, sorry. Try to play more games. So set, Yahtzee, cribbage, anything like that to give the kids some counting. And the last thing is try the Tessellation Project, either the end of this year if you got time or in the fall. It is a wonderful project. And I'm talking from younger kids up until adults like you guys. When I normally do this in the Penn program in this class, I have had so much fun and the students have had so much fun with it. That's it. What do the dealers do at the end when they walk away from the table? What is do you guys know what I'm talking about? Something like, what is it, Justin? Do it again. Is that what it is? To show that they have nothing in that. So that I need to do that. There we go. Walk it away. Okay. So you guys are, well, let me stop the recording. Stop sharing. Give me 1 sec here. Stop recording.